Today is the last day of review material from last year, so that's kind of good because, you know, it's always fun to learn something new. All right, so today we're going to talk about the product and the quotient rule. Product rule is when you're multiplying two things together. If you think of one factor as f and the other factor as g, then the formula for the product rule is f prime times g plus f times g prime. Or what I kind of think in my head is take the derivative of the first one times the second one plus the first one times the derivative of the second one. So for number one, I'm going to think of that first parenthesis as my f and the second parenthesis is g. So h prime is going to equal the derivative of the first parenthesis, or 2x plus 3, times the second parenthesis, 2x minus 5, plus the first parenthesis, times the derivative of the second one, which is 2. And you're done. You do not have to simplify. So obviously the back of the book is going to simplify. What the back of the book is going to do is FOIL all that out, combine like terms, and then give the answer. So use the solutions manual when you're checking your answers. Sometimes the hardest part of using the product rule is just identifying what your two factors are. So on number 2, your first factor is 4x to the third, and your second factor is sine x. So the derivative of the first one is 12x squared times sine x plus 4x cubed. And what's the derivative of sine x? Cosine x. Good. That's all you need to do. For number 3, 4x squared plus 5, the quantity squared, this is using the product rule. So how do you think what do I need to do? Okay, I could FOIL it out and use the power rule, but I don't really like to do that. Good. I'm going to rewrite it as 4x squared plus 5 times 4x squared plus 5. Good. And then you can use the product rule. Does anyone really need me to go through that? No, you don't. All right. Quotient rule, moving right along. The quotient rule is very similar. Think of f as being the numerator and g as being the denominator. Then the quotient rule is f prime of g, or sorry, f prime times g minus f times g prime all over g squared. So the derivative of the top times the bottom minus the top times the derivative of the bottom all over g squared. Okay. Mr. Capetta probably taught you low d high minus high d low over low low. And my students from last year are looking at me like I'm crazy. I actually cannot remember that. I can never remember if it's low d high or high d low to start with. But what this means, it's low d high minus high d low. I do like the low low part though.
You'd always be like, this is the cutesy way. Yeah.
He calls that the cutesy way. All right, so low d high, low means bottom, and then d high means derivative of the top. So the bottom times the derivative of the top minus high is the top, d low is the derivative of the bottom, and then low low is squared. So whatever works for you. I do not care. If you love it, then use it. All right, so number 4. And the only problem with that is I think the reason that I'm not good at using that is I was taught derivative of the top times the bottom instead of bottom times derivative of the top. So the low d high doesn't really work for me. But the derivative of the top would be 7 times the bottom. Or if you're using low d high, it would be x squared plus 3 times 7. But multiplication is commutative. Doesn't matter what order you put it in. Minus the top times the derivative of the bottom. 2x all over low. And you do not have to simplify.
Yeah.
All right, anything you want to do on number 5 first? Okay, so instead of 3 minus 1 over x, I'm going to write that as 3 minus x to the negative 1. So the derivative of the top is x to the negative 2 times the bottom minus the top times the derivative of the bottom, which is 1. You do not need to write times 1. I tend to do that right at first just so I don't confuse people. Or maybe it's more confusing, I don't know. But the quotient rule does allow us to find the derivatives of the other trig functions. Good. Tan x is sine x over cosine x, and that is a quotient. Some of y'all have incredible memories from last year. Tan x equals sine x over cosine x. So now, using the quotient rule, the derivative of the top is cosine times the bottom is cosine minus the top is sine. What's the derivative of the bottom? Negative sine. Now, if you're going to write times negative sine, make sure that you put parentheses around negative sine. Because if you just do minus negative sine, or without the parentheses, it's going to look like a minus sign instead of a negative. But basically, and then over low is cosine squared. So then we have cosine squared plus sine squared. Well, what we're doing is deriving the derivative of tan x, and it's going to be a heck of a lot easier to memorize what it is if we simplify this. Okay, I already heard Logan say it, so we're going to give a big shout out to Mr. C, because cosine squared plus sine squared is called the Big Daddy, and it equals 1. So 1 over cosine squared, and what's in secant squared? Good. All right. Mr. Capetta calls sine squared plus cosine squared equals 1 the Big Daddy. I think I called it last year, but he probably makes a much bigger deal about it than I do. Okay, so to review, what's this d dx sine x? That means what is the derivative of sine x? Cosine x. Okay, what's the derivative of cosine? Negative sine x. We just found that the derivative of tangent was secant squared, x. The derivative of cotangent can be found the exact same way, but you would rewrite it as cosine over sine. Anyone remember? Negative cosecant squared x. Close. The derivative of secant is secant x tan x. Okay, now there's some patterns going on here. If tan's derivative is secant squared and cotan's is negative cosecant squared, close, negative negative cosecant x, cotangent x. So tan is secant squared, cotan is negative cosecant squared, secant, secant, tan, so cosecant is negative cosecant, cotangent. You do need to know the derivatives of those 6 trig functions. But if you forget them, you can always derive them, just like we did tangent. Secant x, you would want to rewrite as 1 over cosine x. So if you take the derivative of 1 over cosine x, what's the derivative of the top? 0. Right. It doesn't even matter what the bottom is because I'm multiplying it. Minus the top is 1, and the derivative of cosine is negative sine, so that's going to be plus sine x over cosine squared. Yeah, it was minus a negative. That's where I got the positive. So I have sine over cosine squared. The sine over one of the cosines is your tangent, and the other cosine on the bottom is your secant. Okay, take the derivative of number 7 for me. And obviously you don't have to put the 1, but I just wanted you to recognize that the derivative of x is 1. I did consider that. All right, 8 is something that's not tested on the AP exam. However, it follows a pattern, and I just want to point it out to you because I think it's kind of cool. I am going to call the first factor g, and the second factor h, and the third factor k. So if I were to take the derivative of a product of 3 factors, it's going to equal the derivative of the first one times the other 2 plus the derivative of the second one times the other 2. And what do you think? Yeah, k prime times gh. Good. I'm not going to go through that, and I don't think I assigned any homework problems on it, but I just wanted to point it out. You won't be tested on it, no. All right, 9 and 10. Now, this is as hard as it gets, and it's a little bit tedious, but if you pay attention to what you're doing, it's not bad. And the good news is, remember, you do not have to simplify at the end. Is number 9 a product rule or a quotient rule problem? It's kind of both, but as a whole, is that problem a product or a quotient? It's a product. You've got this parenthesis times that parenthesis. But when I take the derivative of that first parenthesis, what am I going to have to use? Quotient. Okay, so the derivative of the first parenthesis is going to involve the quotient rule. So the derivative of the top is 4x plus 3 times the bottom minus the top times the derivative of the bottom, all over Lolo. I'm making you laugh. That's good. Okay, so what I have done here, all of that work right there was just my f prime. And the product rule is the derivative of the first and then times the second. So now I need to do, is that x to the third? Plus 5x minus 7. And then plus f times g prime. Yeah, that's it. Okay, so this was f, and then that was g prime. Okay, now number 10, product rule or quotient rule? Kind of both, but as a whole, we need to think of it as a quotient. Right. So the quotient rule, I'm starting with the derivative of the top, but the derivative of the top is going to involve a product. So the derivative of the first one times the second plus the first, and then the derivative of the second is negative cosecant x cotangent x. If I have a product and I have a negative that's kind of towards the end, I really like to bring those negatives to the front because they tend to get lost if you don't do that. Okay, so there's the derivative of the top times the bottom minus the top times the derivative of the bottom. What will the derivative of the bottom be? Cosecant squared x. and then all over the bottom. Squared. Okay. You will have very few problems like 9 and 10, but I just need to make sure that you can use them both at the same time. Okay, the back page is very easy. Okay, what do you think F apostrophe 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 means? The third derivative. Now, unfortunately, there's no way to skip from the function all the way to the third derivative. It just means you're going to have to take the first derivative and then take the derivative of that and then take the derivative of that. Or you can enter it in your calculator 3 times. But if you can't use your calculator, then you're going to have to do it by hand. So the first derivative would be 30x to the 5th minus 3 cosine x. Always label what you are doing. The second derivative would be 150x to the 4th plus 3 sine x. And the third derivative, 600x to the 3rd plus 3 cosine x. So multiple derivatives bring up more physics. Yay. S of t we learned yesterday was the position function. To review from yesterday, what the velocity function is, what relationship to position? The derivative. So s prime of t. V of t and s prime of t are the same thing. Well, acceleration is the derivative of velocity, or we can think of it as the second derivative of position. Good. And then there's jerk, which you do in physics some, but that's the derivative. The derivative of acceleration is jerk, so that would be the third derivative. I've never seen jerk in calculus. Okay, the last part are just, I want you to be familiar with some of the notations. The first derivative is like y prime or f prime of x. For the second, you use 2 apostrophes. For the third, you use 3. Pretty much after the third, they just start putting the number up there. All right, if you're using dy dx, remember dy dx means the derivative of y with respect to x. The second derivative is denoted as d squared y over dx squared. Please don't let that notation freak you out. It basically means you're taking the derivative twice of y with respect to x both times. So if you see d squared y over dx squared, just think y double prime.